recording here. Okay, so we will create a labs namespace as lab services. Okay, so this is the command. Once you do that, you will create a lab services. Then you will be doing a backend application deployment here. Okay. So where you will be running it pods here. So you see these pods you are running it. So you have two replicas. Two replicas will be running on Nginx here. Okay. So now you are going to expose these pods to one cluster IP. Okay. So you can see that there is a cluster IP here. This is not the actual cluster IP. So once you execute this command, so these pods will be connected to a cluster service. Okay. So these whatever pods you are getting it here, the IP address, we call this as ephemeral. Okay, you can see that here. So means they keep on changing. Okay, so if you restart it, or let's say this got restarted or it has moved into a different server, this IP address will keep on changing, but this service backend, it will stay static here. This IP address, it will be static. You will not consider these pod IP addresses. So they are temporary. Okay. So now once you have created this, okay, you will inspect it, and then you will create here front end here, so that the services will come and hit it, and then you can access those services here. Okay, so let me show you that how it will be done here. Okay. So I am going to execute the command here. Like how many nodes we have? So you have master 1, master 2 ready, master 3 ready, worker 1 is not ready, it is having some problem here, and then you have worker 2 here. Okay, so let's create here lab services here namespace. It will say like this is already been created, like you will get an error. Okay. So this, it is already exist. Okay, so now you tell me what needs to be done here. So this all I have executed. So let's see, we'll run this. Okay, busy box. So that if I execute it, it will take a lot of time. So that's why I created one presentation, so that your time will also be saved here. Okay. So first one, the exercise that we will be doing. So you will create a lab services. Okay. So you will deploy backend 2 replicas here, 2 to 4 parts. So here you will be doing only 2 parts here. So you will create it here. So then it will be done. After that, you will be not directly contacting this. Let's say you want to access this from this server. Okay, like you want to access this pod. So you will be accessing through cluster IP here. Okay. So why you need to access it through cluster IP? Let me show you that one. Okay. So you have here backend. So one pod you have it, the other one you have. Okay. So client, this is the client user here. Let's say this is one user. So if he is accessing, he will be accessing through this IP address. Okay. So cluster IP is the default service type here. Okay. So this is going to assign the internal IP address that is only reachable from the cluster here. Let's say you think this one as a internal phone or extension phone of the company here. Okay. Only employees, pods inside this building or cluster can talk to each other or can dial. Okay. You cannot directly access like this. Let's say you want to access it like this, you cannot be able to access that. So you need to go through the cluster IP, then cluster IP will give you this access here of these pods. Okay. So this is what the exercise is all about. So once you deploy the cluster IP, then it will be working here. Okay. So we'll see that in practicals. Okay. So now next lab is, that is first lab. Lab 2, this is your node port here. Okay. So we will be deploying here. The concept here is, so node port exposes the service here. Okay. On each node's IP at a static port. Let's say you are having a static port from 3000 to 30,000 to 30,300, 33,000 till 33,000 you will be running these services here. Okay. So let's say here it is like so anyone can call to our office by dialing any of our building's public phone. Okay, like extension at. Okay. So you can call at our company. Okay, but you can use the extension here. If you use the extension, like you can directly call. Okay. So this is how you will be configuring it as a node service ports here. Okay, that is the second one. Okay. So then you have third lab. So load balancer service. Okay, it is like a cloud style external IP address. Okay. So you have load balancer web 2 pods. Okay. So you will have a dedicated hotline. Okay, this is a dedicated hotline. So in the cloud environment, we will be having a load balancer, something called LB. So this what load balancer will do, it will be distributing the load here. Okay, you have three servers here. This it will be distributing the load, whatever you are facing that. Let's say you have web server here. Okay, so you have application or web service. Okay, this is your web service. So your website, you will be configuring it to a virtual IP address. Okay, so this virtual IP address, it will be configured here 1. Okay, so this got struck here. Even the recording is also struck here. So am I audible? Whether? Okay, now it has released now. Okay, so you have two. We'll take different pen here. Okay. Gray color. Okay. Okay. So three services. Let's say you are running on 2 or 3 pods here. See, I am not calling it as a container or VM here. Okay, you should get familiarized with the topics here. So whenever you request something, web traffic is coming here to your load balancer. So load balancer will be sending the traffic here and here. Okay, so in this example also, so this you will be configuring this mini cube here, mini cube. Okay, so where you will be configuring here, and once the traffic comes to this mini cube, it will be sending it to the respective pods here, where whatever is available. Okay, so 1 2 3, let's say I will give, this is 1, then 2 3. Okay, let's say 3 gone down. Okay, 4 5. Okay, 6 7. Now 3 has gone came up. Okay, now 8 9 10. Okay, then this has gone down. Okay, then 11 12 13 14 15 16 17. Okay, let's say this has come up. Now this will be sending the traffic to this server. Okay, so in all these servers you will be running a web traffic here. Okay, or a website you will be running. Okay, this is how you will be configuring, and you will be checking that particular subject here on the load balancer. So this will be on the external IP address. Okay, so on from the external IP address, you will be placing all the load on these load balancer pods. Okay, that is the third lab. Okay, fourth one. Okay, let me pass it here. Okay, so these are all the networking concepts that we have in Kubernetes. Okay, at the cluster level, at the pod level, at the node level, or load balancing, all that we have those things in the orchestration part. Okay, so you will be managing everything like you are managing the entire cloud here. Okay, so you are not dependent on the Amazon, or you are not dependent on any technology. Okay, Kubernetes will be giving you the complete stack to do whatever you want. The way Google will does is Google Cloud or Azure will do it, or AWS, everything your Kubernetes will give. Okay, that is why they will take this complete setup into their on premises, and they will make it like this is our private cloud. So we don't have to pay anything to any vendor, or we don't have to depend on the other services also. Everything we will build it, everything we can have control. So that is why if you are very strong in Kubernetes, okay, you can go as a platform engineer, and cloud concepts will be you can easily understand all that concepts. I will go back to the document. Okay, so I will open up this document here. Okay, so let me do this all practical. I will do it by myself, and then I will demonstrate it what exactly we are doing it here. So node port services, we will see that how the architecture is. So just now we done the node port. Okay, so node port is you have this architecture here. This is your Kubernetes cluster 1, 2 and 3. Okay, these are all in cluster. So if somebody is accessing the node here, okay, your node IP address, so whether this is any IP address, okay, if they are accessing this, okay, with the IP port here, it will go and it will check on this particular service here. So it is not looking at the particular IP addresses. Okay, direct it is going to check on the target port and then node port here. So whatever you have given the node port here, it will go and it will check and it will give that access here. Okay, so this is the default external traffic, how external traffic will come. Let's say you are on the client side, so you open up and you want to access a website here. Okay, so node 1 is running one pod here. Okay, node 2 it is not running anything here. Okay, so in normal in local traffic, what happens? It will accept only on the nodes that have local pods. Okay, so which will be reserved here. So whereas here it will be giving you that particular access even if there is no pod running there. Okay, directly you can access the server here without any service is running. Okay, it is like so you have a big vehicle. Okay, let's say this is a lorry. Let's say node is like a lorry and pod is like a small two-wheeler. Okay, so here you can access either two-wheeler or you can access it your big lorry also. Okay, that's how you will be doing the node port service. Directly you will be exposing the node here. So that is the second lab. Okay, so then we'll come to the third one. Okay, so you have a load balancer here. Okay, so see, load balancer, now you have assigned the Minikube here tunnel. Okay, so this is how I have configured it on my Kubernetes setup. Okay, so once any traffic comes here on the port 80, so it is going to hit on this load balancer. It is not going to check which server is running. Okay, so this will go to the Kubernetes cluster here, Minikube it will take, and then it will send here based on the algorithm. It is going to push that particular traffic. Okay, that's how your load balancer will work. Okay, these are all the steps that you will be accessing it, that you will be checking whether this is working or whether this is running or not working, all that. These are the steps. Okay, so now fourth one, headless service. Okay, headless service is sometimes you don't want to do any virtual IP load balancing. Okay, you want to direct discover and talk directly to pods directly. Okay, headless service is it will do that exactly. Okay, you don't want to have any interface here. Okay, let's say, so I don't want all these interface, I directly want to talk to these pods. Okay, so I have it here. So there is a lot of middleman here. I don't want this, I want just direct access. So that is what headless service is all about. It does not load balance or do any DNS return. It will be directly, individually you will be accessing it. Okay, so why you will be directly accessing the database is, so for crucial or critical application you should be accessing the database. So that's why you will be accessing that directly, you will be accessing, like if we call it in our terminology, like calling a company main line and getting routed to direct employee. Okay, so that is normal service. So now headless service is getting a directory listing of the direct employee. So you are giving the direct employee number. Okay, you take my direct employee number. So you just dial to my number, you can directly call. So here what you are doing, okay, you are calling the customer service or else the hotline. So can you please connect to so and so. So these guys will route to that particular employee. So you will not know which number it is. Okay, you are just accessing that particular employee here. Okay, so that is headless service. Now we have external name service. Okay, it is like speed dial service. Okay, so now we have it here. This is your external name, external database. So now you are coming it. Okay, so it will not have any endpoints or cluster IP. Okay, you see it, there is no cluster IP, you are directly accessing it. So through it will create a DNS namespace here. Okay, CNAME, where you will be accessing it from the external here. Okay, so this will let you application code. Okay, to use a consistent or internal service name like external DB here. Okay, so this is all about how you are going to access it. Okay, so from the analogy part, if you talk about analogy, okay, it is like updating your phone numbers contact list. Okay, contact name stays the same. Okay, but you will be updating your phone number here. Okay, so you will change the phone number. Okay, once you someone calls it, it will be rerouted to this particular service here. Okay, so let's say why you want to use the external name here is, so you want to use Oracle here. Okay, you want to use some external services. So you will be telling, okay, you go and contact this so and so. So you are running some Oracle server, or you are running some Google database or some other API. So once you are trying to access, you will just give this particular access there, then you will be directly accessing that. That is the lab 5. Okay. So now we have ingress here, incoming traffic. Okay. So where this is the architecture of the ingress here. So this is your client coming it. Okay. You have host here, and then traffic is coming to the ingress controller. Let's say this is like a receptionist. Okay. Ingress is like a hotel receptionist. Okay. What you want? Okay. You want this service. Okay. So which one you want? Which room you want? Okay. I will connect. Okay. You want to connect to kitchen? Okay. I will connect to kitchen. Okay. You want to access gym? I will connect to gym. Okay. I will connect to there. Okay. So same front desk. Okay. You will have the same front desk here. It's like a front desk, and you will be giving it to the different destinations here. Okay. So you want to access any web service, then it will be redirecting to web service here. You want to access any application or API backend, then it will check, or it will reroute on this API. Okay. So why you require this is on the what is this controller. So you will be doing it at the layer 7 here. So this is a layer 7 router. Okay. So I will pass recording here. Okay. Okay. So at the layer 7, you are doing a router activity. Router means it will be sending the traffic where I have to send it. That is the role of a router. Okay. If you want to go outside the network, okay, let's say you are into one company here. Okay, you want to go outside the company, then router will help you to go outside. So here you are doing it at the layer 7 itself. You are routing it. Okay, where you want to go, I will be sending you to that particular service. Okay, or wherever you want to go, I will be sending you to that particular service here. So that is how you will be configuring that particular service here. You see. So let's say you have a web service here, and you have a API. Let's say this is a you are having a huge database of customers. Like you captured lot of information on the import and export. Okay. So whenever some other websites, they will just come and connect to this API, and they will check the records. Okay. Who is the coffee exporters in India? So they will just query from outside. Let's say they query it from outside. Okay. So then it will fetch the information, and it will give it, and it will be displayed on their website. And if somebody wants to access your website here, let's say you are running a website. So if they want to access, this controller will be changing it and giving it to these particular pods here. Okay. So the other reason why Kubernetes Docker is popular, because most of the web hosting companies, they will be using this concept here. Nginx, they would have installed it, and lot of people are hosting the services also in website. So even local parlors also, they have created websites. Okay. Hostinger, you can see lot of ads in Amazon Prime or something like that. Okay. So they will be running lot of web services in Docker or in Kubernetes or in containers. So they will be using all these mechanisms to route the traffic here. Okay. So you will be needing this slash etc slash host file here. Okay. So you can see that somewhere here you see it slash etc slash host file. Okay. So this is again this is a Linux concept. This we have already covered it. So all the concept it should be readily available and you should be referring that. Okay. So once we do this, I will explain this more in the practical aspect, how it will work, all that. So that is for the HTTP routing at the web traffic. Then we have network policy here. Okay. So network policy, if somebody comes in and they will tell, okay, I will do all this stuff, all that. Okay. So I will ask, okay, you tell me about micro segmentation. Okay. If I want to do any interview, this is L3 level question. Okay. So this is not asked for a beginner. Okay, you don't worry. But at least you know what is micro segmentation. Micro segmentation is you are allowing or you are creating multiple layers inside one network. Okay. So by default, Kubernetes is widely open. So that is completely open. Okay. Any pod can talk to any pod. Okay. There is no restriction at all. Okay. So with network policy, you will be implementing a zero trust network. So then again I need to go back what is zero networking here. Zero trust. We will go back here. What is zero trust? So you need to be keeping these keywords in your resume here. So whatever I am teaching you this zero trust architecture. Then in other class I told about SD WAN, software defined WAN. So if you put it all these terms here, then you will get shortlisted very easily. Okay. So I will open up one zero trust. Okay. Let me open up one here. Okay. Zero trust. Or we call this as ZTA. Nobody will call this as ZTA, they will call zero trust only. Okay. So these are all the devices that you have it here. Okay. Oh, this is not good here. Okay. We will go to the other one. So zero trust is, let me open our notepad here. So zero trust. Okay. So zero trust is, okay. So you are from a coming from a normal. This is non-zero. Okay. So you are coming from a external source. Okay. This is a enterprise infrastructure. So you will put login, username and password. Okay. So once you got authenticated here, okay, you are a legitimate user, okay, authenticated. So now you are allowed to access all the services here. Okay. So service 1, service 2, service 3, 4, 5, everything you are accessing now. Okay. With zero trust, what happens is, let's say you entered into the building here. So let's say you entered into one apartment. Okay. So in apartment you have gym. Okay. So you have a swimming pool. Okay. You have a yoga center. Okay. And then you have a musical instruments. Okay. You have auditorium. Okay. So then you have a spa, and then you have a shopping mall. Okay. In one apartment you have all these services. Okay. So you don't have zero trust here. Okay. So normally what happens is, once you enter into the apartment, you can access any service here. Okay. Because you see, I have entered here, so I can access anything here. Okay. With zero trust, what you will do? So you will restrict. Okay. So you got access it here. Okay. You entered. Okay. One layer you have entered. Okay. That is fine. So where you want to access? Which one? Okay. You are allowed to access only shopping here. Okay. 6 service number 6 you are allowed. You cannot access this. So I am going to lock all this. Only if you come here and you will access. Let's say, so other user is coming. Okay. He has only access to swimming. Okay. So there is a apartment here. They are running some services where you can do a swimming also on Saturdays. Okay. They are running service. Okay. Only this he can access because he has subscribed to this. This is called zero trust. Okay. Even if you come inside, I am not going to trust you. I need to see again what level of access you have. That is called zero trust. Okay. So in Kubernetes, so you create one pod. So you have one more pod here. So you create it. So they will talk to each other. Okay. There is no restrictions here. Okay. So this is a security lapse for me. So this communication should not happen like this. I want to restrict. See, I have 200 pods. Okay. So I want to communicate only 4 pods, one application. Okay. I have 8 pods in web service. Okay. So like this I have designated only these pods should be talking to each other. So these guys should not talk. Only if I allow them at the service level only they need to talk. So that is what zero trust is all about. Okay. So we will come back to the document here again. Okay. So now you see it here. So you have front end here. So front end, you are running one service here. Okay. So this is the front end pod. Let's say you are running it here, some 10 pods. Only you allow this front end to TCP 8080 to backend pod here. Okay, and don't allow anything apart from TCP 8080. That's it. Okay, so now the backend pod, you have a service here. Applications are running here. Now they are connecting to database. Okay, so you allow whatever is running here, these pods should be connecting to the particular database. Only they have to be allowed here. So in database, in application tier, I have explained you this. In 3-tier architecture, you will be segregating this and you will be restricting that. Okay, so these pods should not directly access this. Okay, backend pod should not, front end pod should not access this database directly. Okay, so you see front end to back end. Okay, so you allow 8080. Okay, from back end you allow it to database. Okay, so from back end, okay, front end you should be blocked here. Okay, from here you should not be accessing this. From here you can access. Okay, like you are only allowed to answer, not to question. Okay, if it is bidirectional means you can also question. Like allowing is you are allowed to question here. Okay, so this is just answering. So you cannot talk back here. Okay, so I will connect it, you cannot connect me back. Okay, so this is how your network policy will work. Okay, so one is unidirectional, the other one is bidirectional here. Okay, let's say you are going in only one direction. Let's say you are I will take the traffic example here. Okay, this is only one way traffic. You cannot come in opposite direction. So if you are coming in opposite direction means that is bidirectional. Okay, so you are allowing only unidirectional here. See, I can go here, you cannot connect back. I will connect you, so you connect it here. So that is how the service will work. Okay, so this is all the metrics here, how you will be accessing front end, back end, all that. So one thing is you don't worry about if you are not able to understand also. First time and second time this will happen. Okay, so once you start doing the practicals and experimenting it, then you will get to know all the concepts here. From Monday we'll start all these on the cloud. One by one we'll start it. Then you will be able to understand each and every concept. Okay, one we will do it. One lab we will do it. We will have 10 labs. So once you complete those 10 labs, then you will understand the complete AWS concepts. Okay, so that's it for today. Saturday also we will continue. I will demonstrate that. I will have a recording and then I will demonstrate what exactly this is done. And then from Monday we will start on the AWS part pure. Okay. Okay.